Hey everyone, Rudy from IMC, and in this Python tutorial we are going to be learning about lists. So a list is the first sort of container Python type that we're going to be looking at. So we've looked at some sort of simple types so far, like booleans, integers, floats, right? These are all sort of single elements, okay? But a list is a container of other elements or of other types. Right, so it allows you to put lots of integers sort of together in one place, and they're all kind of associated with each other, which is super useful because in daily life we have lots of things that are just groups of other things, right? So it's useful in a programming sense, but let's just get straight into it. I'm going to make a list right here. Numbers. Okay, so there is my empty list, right? Square bracket open, square bracket close. If I try and look at my numbers list, you can see that it is empty, okay? And if I check the type on this guy, right, using our type function, we can see that it's a list, okay? So that is an empty list, which is not super useful for us. So let's put some stuff inside it. I'm gonna put a few numbers in here, okay? So note the syntax, comma separated values on the inside, square brackets, that's a list, and there's our three values, okay? Now, when we have this list, we can do a couple of things with it. One of the first things we're probably going to want to do is to look at individual elements inside the list. So if you want to look at, say, the first element in the list, you put square brackets afterwards, and then you put the index of the element in the list that you want to get out. Now, the trick here is that the first index is actually 0, okay? So this is the 0 element, this is the 1 element, this is the 2 element, okay? So to look at the first element, I use 0. To look at the second one, I use 1. To look at the third one, I use 2. And if, for instance, here I try and look at the fourth element, right, the one in the invisible spot 3, Python yells at me and it goes, nope, can't do it. You're trying to look at the fourth thing, there's only 3 things, unlucky, okay? But as long as we stay within those bounds, it's fine. The other useful thing we can do with indexing is we can actually go, so 0, 1, 2 sort of goes along left to right. And if we go negative, we can actually look at the last element, right? -2, second last element, etc. Okay? So this list I just made sort of here in one go, right? I put all 3 elements in the list. But the other thing we can actually do is we can dynamically add elements to the list as we go. So let's say I make this list and then later on I decide, actually, I wanna put another number on the end of that. Oops. I want a 40 to be on the end of that. We can do it like this. So numbers dot, and then the name of this particular method, this function, is append. So sum list dot append. And then whatever element, whatever number I put in here, or whichever thing I put in here, is going to end up on the end of the list, right? So numbers, 20, 30, 40, right? So now my numbers has 4 elements in it, okay? And in fact, once I've done this, right, I could then go and look at the object in number 3, so the 4th element, and we can see that that's 40, and everyone's happy. Another useful thing we can do with a list is we can check how long the list is. And that we do with the key or the function, the built-in function, len, right? Stands for length. How long is this thing? So if I look at the len of numbers, 1, 2, 3, there are 4 elements in it, and the len is 4, okay? So just something to note here, right? Even though the length of the list is 4, the elements and the indexes will only go 0, 1, 2, 3. Okay, so I could look, if I try and look at numbers 4, right, we still get that error because we don't have that, even though the length is 4. So if you were trying to get the last element, say using the length, right, we would have to do something like this, say. Okay, and then that way we only get the last element out of the list because it's the len -1. Just something to keep in mind. Otherwise, I think that's actually all we need for lists. at least for the moment, right? This is how you make a list. You just put square brackets in. You can put elements inside if you want to, but otherwise you can just make an empty list. You can append to list to add more elements to it, right? And they'll always go at the end. That's what append means, like on the back. And you can use len on the list to see how long it is, okay? So with that in mind, let's hop on over, because Terry's back once again, all right? We've got more Terry action. Cool. Bunches and crates. After a lucrative day at the markets, Terry is packaging up bunches of bananas. He will only put a single bunch of bananas in a crate. Moreover, his crates can only handle bunches of size 20 or less, okay? So for bunches over size 20, Terry will detach the excess bananas and put a bunch of size 20 in the crate. And of course, he saves those remainder bananas for banana bread later. No waste with Terry. Very environmentally friendly man. So what we want to do here is we want to write a function, crate bananas, which takes a list of integers representing the size of various banana bunches and returns a new list of integers showing the number of bananas in each packed crate. Okay, so there's a little bit of text going on here, a little bit of backstory, but basically, if we look at the example down here of crate bananas, we are taking in a list of integers, okay, so similar to what we had over here, and we want to crate these, right, because these are our bunches of bananas. So the crates that come out, remember it's a 1-to-1, so one bunch to one crate, so 18 goes into 18, the 16 bunch of bananas goes into the 16 bunch, goes into a crate. But then when we hit a 24 bunch of bananas, we need to remember to only put 20 in the crate, okay? And the other 4 Terry puts in his fridge for banana bread. 17, 22, once again over 20, so we get a new list. We get 20 out instead in our list of crates here, okay? So really all we're doing is trying to take a list and then make sure that we give a new list back that's capped at 20 for every number. This is a bit more involved than the previous tasks we've done, so I will give you a little bit of a hint before I let you sort of run at it. You need to look at each element in the list, right? And you don't necessarily know how long this list will be, right? I might give you 2 examples here, right? One's length 5, the other one might be length 50, right? We don't know how many banana bunches Terry bought at the markets. So we need to make sure it handles that. And the best way to do that is with a loop. Okay, so we learned about while loops in the previous episode. You're probably going to want to use one here to try and look at each element in the first list and figure out what to do with it. Okay, that's my hint to you. Now, as always, I'm going to encourage you all to have a good go at this. Really sort of play around with it, try and get something going, because this is quite a step up from the previous task. But then pause me now, and I will come back in just a few seconds to work through a solution for it. And we are back to crate some bananas. Okay, so as always, we're going to start off with our function. So our function is crate bananas, and it takes a list of integers representing the banana bunches. So I'm going to call that bunches. Okay, so standard function definition. Hopefully you guys are getting comfortable with using these. Now, there's sort of 3 main parts to this problem, and I'm going to try and attack it sort of one part at a time. So we need to look at each element, or each bunch of bananas, right? We then need to decide whether that bunch of bananas is bigger than 20 or not. And then based on that, we then need to put a set of bananas, or a bunch of bananas, into the crate. Okay, so there's sort of 3 parts to this. And when approaching problems like this, I always like to start with the easy part. So let's just start with, how do I look at each bunch of bananas one at a time? Okay, so let's say I was over here and my bunches of bananas, I was just using this as my bunch of bananas, right? If I wanted to look at the first element, then the second element, right? I need to go look at the first element, which is 0. Then I need to look at the second element, which is 1. Then I need to look at the third element, which is 2, etc., right? And I need to keep doing that until I get to the end of the list. Okay, so I'm going to use a while loop for this because we learned about while loops last episode. and I'm going to make some sort of counter, right? So essentially we need to count 0, 1, 2, 3, etc. So I'm going to start off with a counter, and we want to start with I, and I'm going to say while I is less than, and I'm not quite sure what to put here, so we'll come back to this, but while I is less than something, okay, I'm just going to print it out. We want to be printing out that bunch. So bunch is a list, and we have the ith element of the list, right? So I want to print out bunches 0, then bunches 1, then bunches 2. So while I is less, I print the bunches, and then I need to remember to increase my I by 1. Okay, remembering that this is Python's sort of cheeky syntax for doing this. Okay, I plus equals 1 is the same as adding 1 to it. Okay, so this is kind of the gist of what I want. The question is when do I stop, right? So if my list over here is 0, 1, 2, 3 elements, okay, I want to count 0, 1, 2. But if my list is 5 elements, right, I want to count 0, 1, 2, 3, 4, and then stop. So how do we know when to stop? Well, we've got that len guy that we used before, right? So, actually, did I run that? I did. Okay, cool. So the length of the numbers is 5 in this case. We've got 5 numbers. So len is 5. And if len is 5, we want to count 0, 1, 2, 3, 4. So we want to count up to, but not including the length of the list. So while I is strictly less than the length of the list, okay, we're going to print, we're going to increase by 1. Just to make this a bit more obvious, I'm going to print the I and the bunches of I in the same print. And let's see how we go here. Oops, I set up my function, but I didn't call it. So let's try calling it with this example and see if we get something, well, see if we get these numbers out. Okay, so there we go. So here you can hopefully see what is happening, right? We start off with an I, it's 0, and then we get the 0 element, or the first element, out of bunches, which is 18 in this case. Then 16 and 1, or 2, 24, 3, 17, 4, 22. Okay, so that's the first pass. This is how we iterate through the list, right? That's the word we'll be using. Iterate means to go through a sequence. So that's part 1 right there, okay? So we only want to, at the moment we're only looking exactly at the bunches as they come in. Now instead, let's hit sort of the second part of this, which is if the bunch is greater than 20, right? We don't actually want to print, or we don't actually want to sort of deal with the bunch itself, right? We want to cap it at 20. Okay, so print I bunches I. We need to be sort of looking at something here. So if bunches of I is greater than 20, okay, then what do we actually want? We actually only want 20, or to consider 20. Okay, so let's say that we print I and 20. Okay, otherwise if it's not greater than 20, right, we do the exact same thing we were doing before. Okay, so let's see how this print goes. I need a little bit more space. Cool. So you can see our 24, we hit it and we went, okay, is it greater than 24? Is 24 greater than 20? Yes. So we only printed 20 instead. Okay. So this is sort of the main chunk of our logic here. Okay. And so the final thing that we're going to look at is, well, what do we actually want to do, right? We don't just want to print these things out, right? We want to get a return out of this function that gives us a list of these 5 things, okay? So we are going to need a list, right? That list is going to have to sort of persist throughout our entire loop, okay? And instead of printing these, we want to be adding stuff onto the end of that list. So hopefully remember, I got rid of it on the left here because I was doing the other example, but append is how we add something to a list. So I'm going to make a new list that represents our crates. Okay, and before we sort of start looking at everything, right, we've got our crates lined up, but they're all empty. Okay, so that's why my list has nothing in it. I'm going to look at the first bunch of bananas. I'm going to put it in a crate, and then I'm going to know how many bananas are in that crate. So I'm going to add that to the list. So instead of printing out the 20, what do we actually want to do at this point, right? We want to append 20 to this list. Okay, so no more printing. Same thing down here, except if the number is not greater than 20, right? If it's like 15 or something, we want to put that number in the list. So I'm going to do the exact same thing again. Bunches I. Okay, I'm going to do the exact same thing again. And this is starting to look pretty good. Okay, so I equals 0, crates, if bunches I greater than 20, append 20. Otherwise, we append the bunches, whatever bunch we're looking at, I plus 1. Let's run that and see how that goes. Oh, and of course, we get nothing back because I have forgotten to return our crates guy at the end of the loop. So let's remember to return, our crates once we got to the bottom of the loop. So now we've made that list. Let's actually do something with it. And there we go. 18, 16, 20, 17, 20. Okay, so that is the crate bananas, right? That's a nice solution. We've got our while loop, ifs, sort of starting to use a bunch of stuff, get it all together, doing something a bit more complicated to help Terry out. I will show you one little trick that you can do with this, just to sort of make the solution a little bit nicer. Now, there is a function in Python called min. Okay, and what it does is if you give it multiple things, it will give you back the minimum element that you gave it, right? So the smallest. There's also a corresponding max, which is maximum. Okay, so essentially all we actually want to do here is we want to return either bunches I or 20, right? Whichever one is smaller. Okay, so if bunches I is 15, we want to return 15, right? Not 20. But if the bunch we're looking at is 25, we want to return 20 because that's the smaller of the two. So what we could actually do is using this min function, okay? Instead of having this if statement where we have two things, we could actually replace all of this. Okay, I'm going to comment that out. We could actually replace all of this with, what do we actually want to append? We want to append, okay, it was, so either bunches I or 20, right? We want to append whichever one of these guys is smaller. So I could then do crates.append one of these two. I'm going to just delete this for the moment, clear it up a bit. Okay, so every time we look at the bunch, we basically go, cool, either give me back whatever's in the bunch or 20, whichever's smaller. If I run this again, we get the exact same answer because it's working the exact same way. Okay, and just to sort of prove this, let's change this list up a bit. Let's try it with something else. Let's put some big numbers in. Let's put 19 because that's less than 20. Let's put exactly 20 in, and something big. All right. And you can see, yep, we're still capping at 20. Terry's got a lot of banana bread coming out of this guy at the moment, but that's okay. That's Terry's problem, not us. So that is lists, okay? We've gone through something with the while loop here, appending, creating new lists. Get comfortable with them. They're a really useful structure. You're going to use them a whole bunch. And yeah, that's this episode. I'll catch you guys in the next part.